For this video, we're going to be looking at two different theorems. One is the congruent circles theorem, which tells us that two circles are congruent circles if and only if they have the same radius. So here, circle C would be congruent to circle D if and only if AC is congruent to BD. So that means this if and only if goes in both directions. So if I see that two circles have the same radius, I can then therefore say that those two circles are congruent. Or if I am told that two circles are congruent, I can then say they have the same radius. They are both those statements lead to the other. And then our second theorem is the congruent central angles theorem. And that tells us in the same circle or in congruent circles. So definitely don't forget about this part when we go through some examples. Two minor arcs are congruent if and only if their corresponding central angles are congruent. So again, this one goes both ways. Here I see that my central angles are congruent. So CAB is congruent to DAE. That would therefore mean that my arc CB is also congruent to my arc DE. Or the other way around. If I'm given that my arcs are congruent, then therefore their central angles are also congruent. However, this only works in two different scenarios. First, if they're the same circle, like we see here, these are the same circle, or in congruent circles. And so we'll see that in a second. So for these examples, we're going to be identifying congruent arcs. We're going to tell whether the red arcs are congruent, and then explain why or why not. So here I have my red arcs DC and EF. These are on the same circle, so I can use this congruent central angles theorem. And so this tells me that if their corresponding central angles are congruent, then the arcs are congruent. I see that for both DC and EF, its central angles are both 80 degrees. And so I see that DCB, or DBC, sorry, is congruent to angle EBF. So this means that these arcs are in fact congruent. So arc DC is congruent to arc EF by this theorem above, by the congruent central angles theorem. Okay, let's look at this next one. So here I have my arc RS and arc TU. So I see that both of these arcs have the same central angle of 90 degrees. So those are congruent. So it's really tempting to say, well, then therefore that means that RS is congruent to TU. However, this is actually not the case. So the answer here is no. And the reason why is the circles aren't congruent. So this first example, I was looking at two arcs on the same circle. Here, I'm looking at two arcs on two different circles. I have this smaller circle that's inside of this larger circle. And in order to use this congruent central angles theorem, those two circles have to be congruent, like I have underlined right here. Here, I can clearly see these are not congruent circles, so therefore these arcs will not be congruent. Okay, and then looking at number 3, I see I again have two circles here. So I know in order for these arcs to be congruent, they first need to be coming from two congruent circles, and their central angle needs to be congruent. I do see that their central angle is congruent. They're both 95 degrees. So angle UTV is congruent to angle YXZ. And then looking at these two circles, I see from this tick mark that their radius is congruent. And we learned from the congruent circles theorem that if two circles have the same radius, then they are congruent. So since these two have the same radius, they're congruent radiuses, circle T is congruent to circle X. So therefore, we have that UV is congruent to YZ. So the answer here is yes.